Hey there, in this video we are going to cover radicals and the Pythagorean theorem for our RISE test at the end of this year. So let's go ahead and get started. So first off, it asks, what is the value of the square root of 81? So remember that what the square root is I am trying to find what value multiplied by itself gives me 81. Now I know that 9 times 9 is 81. So because 9 is multiplied by itself to give me 81, I would say that the square root of 81 is equal to 9. Now, that being said, this next question says, find two consecutive, that just means next to each other, whole numbers that the square root of 89 lies between. Now, the way that I'm going to go ahead and calculate that is one of two ways. One's definitely faster than the other, but I'm going to show you both. So the square root of 89, if I am trying to find what two whole numbers is between, I'm going to figure this. I'm going to think of some perfect squares now that are close to 89. Now I know 81 is a perfect square, and I know 100 is a perfect square. Remember that the square root of 81 is 9, and the square root of 100 is 10. So the value of the square root of 89 is going to be between those two whole numbers. So these are my two whole numbers. The other way is just to type it into my calculator. So the square root, the square root of 89, and I see that my decimal is 9.4, so I know that 9.4 is between the whole number 9 and 10. Let's look at our next example. So the next question says, use an Alex calculator to approximate the square root of 116.9. I can do that similar to what I just did. This one says round to the nearest hundredth. So 116.9. So the square root of 116.9. Whoops, I missed a value. And it says nearest hundredth. That's 2 decimal places. So 10.81. And the 2 after the 1 says, yeah, keep it. So 10.81. The next two ask me to simplify. Now I want you to make sure that on this one this is not a decimal. When the problem says to simplify a square root sign, it's not asking you to give me a decimal. It's asking to leave it in radical form. So I probably will most likely have a radical in my answer. Now remember how to do this is the following. I'm going to factor 50. What multiplies together to give me 50? 10 and 5. What I'm looking for is any duplicates of the same number, because remember, a number multiplied by itself is a perfect square, and that I can take a square root of. So 10 is a factor of 5 and 2, and notice I cross out whatever I split because I don't want to reuse any numbers. These are all factored as much as possible, and if I rewrite them in order from least to greatest, 2 times 5 times 5, I notice I have 5 times 5. A number multiplied by itself is a perfect square, so this right here can be pulled out. I can pull out a 5. The square root of 5 times 5 is 5, and it does not have a pair, so it remains on the inside, and so my answer would be 5 square roots of 2. Let's look at another problem. So what if I have 75 and a variable? Let's focus on the 75 first. We're going to factor it. If you're not sure what it divides by, here's a couple options. I can start by saying 75 divided by 2. Nope, that's a decimal. 75 divided by 3. Sure thing. 75 does divide by 3. So 75 splits into 25 and 3. And I know 25 is a perfect square. It splits into 5 and 5. So if I rewrite my square root, I have 3 times 5 times 5. There's my perfect square. And I'm going to pull out a 5. What remains on the inside is a 3. Now let's deal with the variables. This is x times x times x times x. remember, in order to pull something out, it has to be a perfect square. It has to have a pair. So x times x, I can pull out an x, and that comes out front. X times x, I can pull out an x. How many x's is that? That is 2. So very final answer would be 5x to the second power, because there's 2 of them, to the square root of 3. Okay, so what if I have this? So again, factor. If you're not sure what it divides by, just start with the smallest. 24 divided by 2 is 12. So 2 and 12. 12 splits into 2 and 6. 6 divides into 3 and 2. So if I rewrite my radical, I've got 2, 2, 2, and 3. I've got one perfect pair. So I'm going to pull out a 2. And I am going to leave the 2 and the 3. That's not 23, that's 2 times 3 on the inside. So I'm going to have the square root of 6 on the inside. Then I have 19 to use. Now I could write it out the long way, u, but you get the idea. I'm going to start pairing them together. Now how many pairs am I going to have? Well, 19 doesn't make perfect pairs, but I know that one less than that, 18 does. That makes 9 equal pairs. And 1 left over. So when I rewrite this, 9 perfect pairs come out. So u to the 9th power on the outside and 1 left over on the inside. So I've got 2u to the 9th square root of 6u. Radicals, adding and subtracting them is the same as with scientific notation. If these are the same, I can just combine. 5 minus 3 is 2, and I bring down my radical. Now if it is not the same, then I need to simplify and factor them to get the same radical. So I'm going to factor 20 into 2 and 10, and 10 splits into 2 and 5. I'm going to leave the negative on the outside and rewrite this. So I've got 2, 2, and 5. So perfect pair that comes out. So I'm left with negative 2 on the outside and 5 on the inside. Now my goal is to get a 5 on the other one. So I'm going to factor this, and I know that's 9 and 5 and 3 and 3. I'm going to leave the negative 4. So I'm going to bring down the negative 4 right here, and my radical and my inside factors. I find my perfect pair, and I'm going to pull it out. Now remember, if there's already something out there, I multiply. So negative 4 times 3 is negative 12. And I leave an inside radical of 5. Now that these are the same, I can just combine. Negative 12 and negative 2 give me negative 14 radicals of 5. When I multiply, I don't need them to be the same. In this example, they are. So let's say I multiply them. Square root of 6 times 6. That's a perfect pair, and I can pull out. So my answer is just 6. On the other hand, I might have a problem that looks like this. So the radical of 8 times the radical of 2 is the same as the radical of 8 times 2, which is the radical of 16, and the radical of 16 is equal to 4. Now that was radicals. Let's talk about something else that involves radicals, but is going to involve a slightly different process. So whenever I encounter right triangles, there is a theorem that I can use to find a missing side length. It's called the Pythagorean theorem, and it says that a squared plus b squared is equal to c squared. Remember that a and b are the two sides that make up the right triangle. So I could label this a and I could label this b. It doesn't matter. Those are interchangeable. But I usually like to label the smaller one a and the bigger one b just to keep it straight. And my longest side, or this side across from my right angle, that diagonal, is going to be c. So if I am going to use my Pythagorean theorem, here's what's going to happen. I am going to take 7 and I'm going to plug it in for a in this equation. I'm going to take 24 and I'm going to plug it in, and I'm going to leave c as c. So 7 squared is 49. 24 squared, that one I can't do in my head, is 576. I'm going to add those together. 49 plus 576 is 625. Now that's not my final answer. Remember, this is c squared. So how do I undo c squared? I am going to take the square root. So going back to my calculator, handy dandy, square root of 625 is 25. So c is equal to a length of 25. Let's look at triangle 2. What am I going to do here? So again, I have 3 sides. My hypotenuse, or my long side across from my right angle, is always C. And let's call this A and call this B. So I have x squared, or a squared, plus 10 squared is equal to 18 squared. Now, in this problem, notice that there's an equal sign as a barrier. I can't just add the 10 squared and 18 squared. So I am going to isolate x squared by first simplifying both sides. 10 squared is 100. 18 squared, let's use our calculator for that. 18 squared is 324. Equals 324. To isolate the x, I'm going to minus 100. So that is 224. And I'm going to take the square root of 224 for a grand total of 14.96. And that is my final answer for that one. All right. Last couple problems, so let's put this one into context. So it says I've got a 32-foot tile building, and it casts a shadow. So here's its shadow down here. The sun hits the roof and makes that shadow. The distance from the tip of the roof to the tip of the shadow is 35. I'm going to find my last side length. So again, a squared plus b squared equals c squared. This is a. This is not b. This is c because it's across from my right thing. So my missing side must be b. So 32 squared plus b squared equals 35 squared. So let's go ahead and calculate that. So clear all. 32 squared is 1020, and 35 squared is 1225. So 1024 and 1225. 1024 plus b squared equals 1225. Draw my line down my equal sign. Minus 1024. 1225 minus 1024. So 12, make one more line. 1225 minus 1024. And I like to click that blue button on this calculator because it leaves those numbers for me. I don't have to memorize it. So 201. Now remember that my answer is not 201. I need to take the square root. So the square root of 201 around to the nearest tenth, that is 1 decimal place, and 14.1, that 14.1 is closer to being 14.2 than 14.1, so 14.2 meters. On this example, you'll notice I have 2 right triangles. So I've got this big right triangle and this smaller right triangle. My goal is to find the length of RU. So notice where RU, it's this little section between here and here. And it's the only side length that's not measured. Now, how am I going to find that? Well, if I only knew what this length was right here on this small triangle, I would be able to find that one missing length. But I don't know what it is. and I can't use just one side length to find it. So I'm going to use my bigger triangle to find this little length of it and use it to find that, that tall length. So we have the following setup. So first off, I need to fill in a squared plus b squared equals c squared with, this is my c, that's my hypotenuse across from my right angle. We'll call this a, we'll call our unknown side b. So 35 squared plus b squared equals 37 squared. I'm going to draw my line down my equal sign. Now, one thing that might save me a step is you can subtract 35 squared as long as you type this all into your calculator. So 37 squared minus 35 squared. So 144. B squared equals 144. Square root of both sides gives me 12. So B, this tall length right here that I'm going to erase all that writing, is 12. How do I find now my missing side? Well, I do it again just for this triangle. So 12 squared. Now this is A or B. We'll be consistent. Let's call it B. We'll call our unknown side A, and this is C because it's across from the right angle. So we have unknown squared, a squared plus 12 squared equals 15 squared. A squared is still a squared, 12 squared is 144, and 15 squared is 225. I'm going to subtract 144 from both sides. So 225 minus 144 is a total of 81. A squared equals 81, and the square root of A is 9. So my final answer is 9. The last two problems have to do with distance between 2 points on a graph. So if I'm looking at this problem, remember I can't just count this as one diagonal. The diagonal is 1. I can only count vertical or horizontal distance as 1. So if I want to find the length of the diagonal, I'm going to just find the length of the huge diagonal by finding the vertical length and the horizontal length. And using the Pythagorean theorem, our a squared plus b squared equals c squared, to calculate that. So we'll call this a, we'll call this b, we'll call this c. This side gets to be c because it's across from the right angle. So how long is a? It's 1, 2, 3, 4, 5, 6 units. How long is b? It's 1, 2, 3, 4, 5, 6 units as well. So I have 6 squared plus 6 squared equals c squared. 6 squared is 36. 6 squared is 36. 36 plus 36 is 72. And I'm going to take the square root of 72. So clear, square root of 72 is 8.485, and it asked me to round to the nearest hundredth. So that's 2 decimal places. But remember, I'm not just going to put 8.48 until I look after my decimal, that 8, and I see that should be rounded up to 8.49. Last problem asked me to calculate the distance between these 2 points. Now I can do the same thing, find the vertical distance and the horizontal distance. Okay, how far is it from, this is at 7. Now if you're not sure, you can look up at this point. This is at 7. And this goes all the way down to a 3. So what is the distance between the two? That's a distance of 4. What's my horizontal distance? I'm going from -6 to -2, which is also a distance of 4. Okay, so if my distances are that, I can use a squared plus b squared equals c squared. So 4 squared plus 4 squared equals c squared. 16 plus 16 equals c squared. 32 equals c squared, and the square root. I'm going to round to the nearest hundredth. So the square root of 32 is 5.656, I'm going to look after that 6.5 to see if I should round it up to 6.6. And yes, I should. So 5.66. And that right there is my last question. If you have any problems that you need extra help with or clarification on, please reach out and have a great day.